So I had to do green architecture, but I kind of went a bit far into it, I think. And that climbing person there definitely isn't there for any specific reason. But let's start at the beginning. 252 million years ago, the Permian-Triassic Extinction occurred. Scientists term this the Great Dying. During this, more than 90% of marine organisms and more than 75% of organisms living on land went extinct. This was due to volcanoes erupting and pouring thousands of tons of carbon dioxide and other dangerous gases into the atmosphere. Does that sound familiar? Now the next extinction is the Holocene Extinction. And it's happening right now. We've got front row seats. This is mainly because of humans' influence and because of how much carbon dioxide we put in the atmosphere every year. The rate of extinction at the moment is between 100 and 1,000 times greater than before humans. So if one species has never done this before, we should be quite proud of ourselves. The Permian-Triassic Extinction, the carbon dioxide levels were at around about 0.25%. We have just increased ours from 0.04 to 0.03 to 0.04%. So we're getting there. And this was actually predicted almost 70 years ago, so we don't really have an excuse. What caused this? Well, basically, I've narrowed down humanity to a little cycle in which the economy is powered by products and energy, and that in turn produces products for society to consume to produce stuff for the economy. And this whole cycle needs resources and land. And of the land on Earth, 37% of all of it is already used for agriculture alone. And the Earth can only sustain about 100 billion more hectares of forest, and we need about 6 billion more to fix the carbon dioxide levels in the atmosphere. So we don't have enough. And then the outputs of this are pollution in the form of greenhouse gases. These come from deforestation, fossil fuel burning, obviously, meat and dairy farming, and also production of cement, in which they take calcium carbonate and burn it and produce more fossil fuels, and then it produces lime for cement and then carbon dioxide. And then our overconsumption of the environment is leading to resource depletion, ozone depletion, habitat destruction, biodiversity loss, deforestation, desertification, and ocean acidification, along with many more. And this is all just getting better because of population growth. So now what are we going to do about it? Well, we've got to have more sustainable resources and energy, and we can also find ways to actually go out and clean the environment. Now let's start with the energy part. Fossil fuels is off the table, you don't want that. So what about nuclear? Nuclear energy is expensive, and then the waste that remains radioactive for a long time, it's also expensive to dispose of. You need to bury it and stuff like that. And I think it's worth it. It's also very inefficient because we only end up harnessing about 10% of the uranium used. And until that becomes more efficient, I don't think we should use that. How about electric cars? Well, this is so we don't burn gas, right? Or petrol in our cars. But you need to charge it. You plug your car into the wall and it charges. That uses the energy from the grid, which is from power plants, which is carbon dioxide. How about hydrogen cars? When you use hydrogen gas to power your cars, well, to process hydrogen, they process fossil fuels still, which is still carbon dioxide. So, not really getting it. Let's go with the green energy. Wind turbines, they're good, right? Well, you need about 30,000 tons of cement in the base of each wind turbine. Cement's bad. And they only last about 20 years, which all in all is like a fraction of time compared to how much time you will need to produce clean energy. Solar panels. During the production of the solar panel substance itself, they take quartzite and they mix it with pure coal, and then they burn that in more coal to make solar panel, which is more carbon dioxide. And they only last 25 years, which is also relatively short. And then what happens if there's no wind and no sun? Well, you would need a nuclear or coal power plant running in the background, and you can't turn it off because it'll take a lot more energy and resources to turn it back on again afterwards. So it constantly needs to run, which doesn't really fix the problem. Then there's something else they call biomass burners, which involve burning of wood chips. America basically invented this, and they used this in a time where they were being shouted at for not being sustainable. And this was also a way for them to get rid of their wood chips. But what they ended up doing as a ploy to be sustainable, they went and cut down trees and turned them into wood chips to burn them. And the trees are our friends. And then they also substituted the wood chips with tires and stuff like that because the wood just didn't burn hot enough. So not this one. Then lastly, we've got biofuels. There's quite a few different ones. Firstly, we have biofuels from animal fat. That's not really efficient because if you're farming the plants to farm the animals, why don't you just use the plants, and it's not a very pretty process, trust me. You could use grass. Grass also isn't quite efficient. They do use it in some places, but you don't really think fuel when you think of grass. Another good one is using seaweeds. But if you account for the climate change, global warming, and the ocean acidification, their environment is just not going to be able to sustain the amount that we need. What about algae? Well, algae is a unicellular microscopic plant-like protist. This means it does photosynthesis, so it eats carbon dioxide and spits out oxygen, which we like. Now, why are we going to use algae? Well, photosynthesis is way more efficient than using solar panels, for example, because it's been adapted through millions of years of plants adapting. And some algal systems have been referred to as photobioreactors. Why are we going to use other plants? Like, why specifically algae? First of all, algae is really easy to grow. All you need is sunlight, carbon dioxide, water, and nutrients. And it's also a lot simpler. For example, with a tree, you get roots, stem, leaves, flower, fruit, and seeds. Algae is actually just 50% oil and 50% biomass, depending on your species. So the 50% of oil can be used as fuel. This can be produced to ethanol, biodiesel, gasoline, and even jet fuel. And it ends up costing between $2 to $3 per gallon, which is half the price of normal petroleum. It's also easier to produce compared to other biofuels. For example, sunflower oil, you get about 100 gallons per acre per year. With palm oil, you get about 600 gallons per acre per year. With algae, you get between 2,000 and 5,000 gallons per acre per year. And then plus, it's more efficient than petroleum, so you need less to power your car for longer. Now the 50% biomass that I spoke about, that's basically food. I know what you're thinking, I'll get there. Algae contains omega-3 and 6 fatty acids, which is what we need for our proteins. To get this from other plants, you need to eat plants like grains, so maize and oats, for example, and then also pulses, which are like beans and lentils. And you can get 7 times the amount of protein in algae compared to soybeans in the same amount of land. Algae has vitamin B12, along with A, B1, B2, B6, vitamin C, and vitamin E. And then also the minerals, potassium, iron, magnesium, calcium, and iodine. With a corn plant, you only harvest it once a year because it's a seasonal plant. And you can get about 7 tons per hectare. With algae, you can harvest it twice a week. And in some instances, you can get about 14 tons per hectare. This in a year ends up being between 100 and 200 tons per hectare, compared to the 7. This is because of how simple algae is, and it's able to double its mass every 1 to 2 days. I went and collected algae from a nursery owner who's actually very smart, and he actually brought this up when I was speaking to him. Meat, you get about 3 tons per hectare per year. But luckily now that we have enough protein in algae, we don't need to eat meat, right? No? Okay. Okay, well, if you're still into that, then don't worry, because we can feed the animals algae instead of crops that will take up more land. Now, I know you don't really want to eat algae, but think, have you ever eaten sushi? That green stuff on the outside, that's algae. You can actually get algae chips and algae cookies. I've eaten algae chips before. They're like those pumpkin and beetroot chips for the fancy rich people. Yeah. Also, algae is 5 times better at sucking up carbon dioxide than other plants. And it produces 40 times the mass per hectare compared to terrestrial plants, and this is 80 times the mass of animals. It can be used in cosmetics, and it can be used in fertilizers. I joined a meeting with the Los Angeles Ferns Society, a Zoom meeting this weekend, and they spoke about algae being in fertilizers. Now, how are you going to grow algae? Well, first you need the optimal conditions. So you need your sunlight, carbon dioxide, optimal temperature, water, which can be fresh water or salt water. So for example here, I think we've got a freshwater algae. It doesn't look very happy. That was freshwater algae. And then we've got saltwater algae that I collected from the lagoon. Yeah. Cool. And then also you need your nutrients, which is basically nitrates and phosphates. But you can get these from human waste, so like food and sewage. And what you do is you take the sewage and you process it through a bacterial digester, and you end up getting carbon dioxide, which, yeah, it's bad, but it's gonna break up in nature in any case. You get methane, which you can use as a natural gas for energy, and then you get a substance called effluent, which is actually a great fertilizer, and it allows algae to be grown 500 times faster than it usually does in nature. Now there's a few main methods we can use. That is the trough farming method. This produces about 30 tons per hectare per year, and it can be made more efficient by putting a layer of transparent liquid over the top, which reduces the evaporation by 90%, a liquid like oil or even a plastic substance. It can be done in deserts because algae can tolerate extremely high temperatures. And once you harvest your algae, you can take 90% of the water and put it back into the system. And then you can use salt water for certain species of algae, which reduces your need to use fresh water in drought-stricken areas, which also creates a whole new form of industry. The next method they use in Shenandoah in Iowa in America. This is basically a big greenhouse, and they've got these long rows of towels, and then you get a species of algae that grows on the towels, and that place is kept nice and humid with the correct nutrients and stuff. And then you have, you can't really see it, but there's a robot thingy that blows off the algae, and then that's how it's harvested. And this produces about 14 to 50 tons per hectare per year. Then there's the better methods. This is the Omega method, which stands for the offshore membranous enclosure growing algae. It's very creative, I know. This, along with the next one, will produce between 100 and 200 tons per hectare per year. This one it's a very new technology, and they basically take these systems and they grow the algae in these tubes, and they'll put these out in a lagoon or somewhere that doesn't have rough water, which allows us to utilize that area that wouldn't usually be utilized. Next is the Ecoduna method. This is a company from Austria, I think, and what basically the tubes allow for a closed system. So what you put in is what you get out, and as the algae goes along, you can't really see it here, but they put the baby algae in, and then as it goes through the tube, they eat and then it becomes a much darker green compared to in the beginning, and it eats all the nutrients and it's processed. And you can further increase the productivity of these plants by adding in a fuel processing unit in which the algae is compressed through high temperatures and pressure and turned into oil, algae oil, in a few hours compared to what nature can do in millions of years. Now, that is one of the best methods to make sustainable fuels and have a sustainable form of fuel security. Now we can go into physically cleaning the atmosphere from carbon dioxide. But there's still that thing about we don't have enough space for forests. But forests are still a really good form. So regenerating a forest is termed an artificial ecosystem, with an ecosystem being a biological community of organisms in the physical environment. But the way I propose we make artificial ecosystems is through vertical gardens. Okay, that's my phone ring. I made it myself. And you can go to the next picture. I'm initiating my own little vertical garden. As you can see there's a Bromeliad. I'll get to that. Fern plants. I didn't steal those from the wall of the school, definitely not. Well, why? Oh, you can go to the next one as well. And you can see here the roots, because it's spring, they grow and they stick to the brick itself, which is why some plants do really well. I'll get to that now. Well, why do we want vertical gardens? Well, in cities they can create space for displaced organisms that were shooed away by people building the city, and then they also increase biodiversity. So birds and bees and stuff can come in and you'll have more animals in the city. This also reduces the chances of those organisms coming in and going extinct. Besides reducing carbon dioxide, it also filters the air from dust particles. If you think of the air flowing through a city, all of the dust is going to be deposited on those moist plants. And this will actually aid to the fertility of the soil. That's why you get plants growing in gutters. It'll reduce noise, and then it also increases environmental awareness. You're not going to see a beautiful forest in the city and toss a can next to it. And then it also improves mental health. If you're sitting in your little apartment building, you know, there's a blank wall, you're doing your work, it's not going to be... But if you look out and you see a massive, beautiful garden, you think, wow. So this ultimately increases your well-being all around, and then productivity and creativity. There has been measures done between just a normal wall and a vertical garden wall, where there's been a difference in temperature of up to 17 degrees Celsius between both of them. So they double as insulation for that building, which means you don't need to spend a lot of your energy on heating and cooling systems, which means less energy you need, less fossil fuels being burnt. Now, what do you put in an artificial ecosystem, organism-wise? Well, let's start with the animals, and the small animals, being insects. These are for pest and weed control. They eat plants that grow too well. Then they can supply food for larger organisms. They help in pollination for the flowering plants, and then they help with decomposition of soil, which is important to have fertile soil, especially on a wall where there's not really much. Big animals, mainly in environments, just maintain a balance, like wolves, controlling numbers of deers or something like that. But you don't really need them if you plan a living wall and organisms properly. Bacteria help with decomposition, which is good for your soil, and then certain bacteria also fix nitrogen from the atmosphere. Nitrogen is one of the key components in plants and animals' proteins, and that's the only way we get nitrogen out of the atmosphere, is bacteria. Fungi, well, they also help in decomposition, but they're also very good at symbiosis, which means that they live with other plants. So fungi and algae produce lichen, and then you also get fungi that grow in the root tips of some plants, which allows them to speak to each other, basically. Say oh, there's a drought coming, or it's too hot on this side, and then they also increase the absorptive surface area on the plant's roots. Sorry. Okay, now algae. Algae are the base of most marine ecosystems, and this is because of how well it grows. So it produces a lot of energy for oceans, and then they suck up a lot of carbon dioxide. But you can't really use algae on a wall. Or can you? I'll get to that now. Now we go to your mosses. They kind of just help seeds germinate and some bugs live in them. But they don't do much else. If a moss wants to grow on the wall, I'm not going to stop it. Now comes ferns. You can go to the next slide. Yes. So I'm going to give you some examples, but the reason ferns are so great is because they are extremely good at adapting to different environments. And this is because they had to millions of years ago in order to colonize the land. And this is why we have trees all around us, because ferns adapted to trees, basically. So I'm going to start with your glossy hard fern. Got a bit damaged, but it's okay. This is the same one as last time. It's actually grown a lot. This is known as, scientifically, it's Lechnum punctulatum. And the reason I chose this one is because it's got a bit of a red pigment. You can't really see it now because it's been in a box for a while. But this helps it, protects it against like a lot of sunlight. And a few of the ferns that I'll speak about now will be mainly for sunny sides of walls. Another good thing about it is it's got a relatively thick cuticle, which allows it to prevent it from losing water. And then it's got rhizomes that grow into the rocks, and then if it gets too hot, its fronds may die, and then it'll just grow back up again. This fern in particular actually grows on mountaintops here in the Nickel Mountains. Then we've got your holly fern, which is Sartomium fulcatum. This has an extremely large cuticle, which allows it to prevent it from water loss as well. And it's very good at living in environments with a lot of daily minerals. For example, here is on a cliff face on a coast by the water, which is a lot of salt, which ferns definitely don't like. That's actually where I collected this specimen when it was a baby. Okay, here you've got your sword fern, which is Nephiletus cordifolia. This is the same one species that's growing on the wall there on that side of the school. This one I just wrapped in some soil and some moss. It's actually called Cocodama, this technique, and that explains how easy it grows. It's actually mostly invasive in a lot of places, which means it grows well for our purposes, and that's because it grows stolons, which are like thin roots, and then more plants come up after that, also like this one. Next. Okay, here we have your tooth brake fern, or Pteris dentata. This doesn't really like hot temperatures, but it can grow in a large amount of sunlight. And it's also quite a weed. I found the species growing on the walls at school as well. And it reproduces very fast when it makes its spores or its seeds. And then lastly, I think, no, almost last. This is for the shadier sides of the walls, which is your maidenhair fern, which is your Adiantum capillus vitneris. That one, it grows its rhizomes into the wall, and then if it gets too hot, that exact plant there actually got too hot once, and all its fronds died. And a few days later it was pushing out new fronds. So that just shows how durable it is compared to those temperatures, and then it's also really good at growing if it's happy. And then lastly is quite a rare fern. This is your Polypody ensiforme, or one of the polygram ferns. This fern only grows on trees and rocks. It can't grow in normal soil. That's why it'll probably be really good for what we need it for. And its root system is extremely good at holding on to things. You even struggle to get it out of the pots. Okay, next we've got your... okay, that's okay. Next we've got your flowering plants. There's not all of them we need, but I've just got two examples here because I'm a bit racist when it comes to ferns and other plants. First, you've got your orchids. this one specifically got a bit damaged on the way here a few days ago, so I gave it a little spoon. And it's still alive, which is pretty cool. The reason I've chosen orchids is, one, for this species in particular, is an invasive species from where it comes from, and also you can't really see, but they've got extremely thick roots coming around here. When they grow onto the soil or any rock or something, they grow and they mold onto it, and that helps them to really stick onto the soil, which will in turn help all our other plants to stick without falling off the wall. Then you've got your bromeliads. These are mainly from South America and Asia. You've actually only got one species, one type of this plant, and there's millions, from the whole continent of Africa, from the tropical areas. The reason I chose bromeliads is because they're really good at growing without soil. This one actually doesn't have roots. I just pulled this out of my wall at my fern ranch. And the other reason is that how it feeds is it holds water and leaves and stuff in its little urns or its little buckets, and then they decompose, and that's how it gets its water and nutrients. This creates a little environment of its own for frogs, bugs, tadpoles. Also, I've seen ferns and even trees growing in these at the nursery I spoke about earlier. And this can also increase the humidity of your environment on your wall a lot because of how much water they actually hold, as you can see here. No. Okay, that's all the flowering plants. They produce surface area for other organisms and plants to live on, and they supply food for herbivores, and they also suck up a lot of carbon dioxide. So what ones are we going to pick? Well, not the big ones, because you can't really have big trees or wolves on a wall. And the small ones are a lot better because you need less surface area and you can get more of them. If you think about it, like if you take two equal sized buckets and you put a lot of small marbles in one and you put really big marbles in another, you'll be able to get more volume of small marbles than the big marbles. That's why you can fit more small organisms. And then they're also more efficient, as with the algae, 50% oil, 50% biomass. With, for example, crickets, they are carnivores and herbivores, so omnivores, and they're decomposers, and they supply food in the form of cricket meat to your other organisms. Now, what do you need to build a living wall? Well, first you need your structure, and there's two main components: the frame, which consists of the base that you're going to put your plants on, and also the soil or the food source that you're going to feed to your plants, or just whatever you're going to have them root onto. Then the second part of the structure is your support. You may need support for walls if your plants are too heavy. Some plants actually pull down trees in the Amazon. So then also you need irrigation, just watering, and a way to feed your plants, because they still eat like us. Not exactly like us. One of the best constructions I think would be to use is you basically take your wall, and you put a substance down to prevent water from going between the wall and the building itself, so that it doesn't damage it. And you can put some substance like a mesh. They call it bidone, is what they use. And you put 2 layers of that, and then you can cut open the first layer, put your plant in, shove it in, staple around it, and then that'll live there properly. This doesn't use soil, but I'll get to that now. Then you can run your pipe up at the top. You can put the bidone over it, so that when you plug your little part of your pipe into your tap and it starts running water, it can make the whole wall moist from the top down. And yeah, that's the irrigation. And then it comes to feeding. You can use foliar applicant fertilizers, which you spray on the leaves of the plants, or you can use soil, but soil is heavy and it's difficult to keep soil on a wall. One of the methods I thought might be good is to put the liquid fertilizers into the pipes. And another thing, if you had a fish farm nearby, and this will reduce the ocean destruction, because you won't need to fish as many fish and destroy ecosystems and whatnot. Fish, and maybe process them if you need to, and you can pump them into this, and this creates a whole different type of fertilizer for the wall that's also very sustainable. And what are you going to feed the fish? Algae, yes. So now, stay. Now that we've got a lot more surface area, for example, if you have just a little piece of land and you grow a forest, you can get so much carbon dioxide out of the atmosphere to get to the structural part of the tree. But if you build a building and you build a forest all the way around it, like this, but on a larger scale, then you can actually create more surface area for forests on the planet. And you can further increase the ability for buildings to hold plants by improving their surface area, like the next picture. Like that one. They've got balconies and all sorts of things to improve the ability to hold plants. Now, if we can do this enough, we can end up maybe having enough surface area to get enough forests we need to fix the carbon dioxide in the atmosphere. And yeah, that's how I think we should have more sustainable fuels, more sustainable food security, and then clean environment. Thank you. Structural support. There are methods that certain engineers can use to do that. Then also, as I said, you don't really need to use the wall itself. You can put a wooden frame up, then put the plastic on that, staple that on, and then put the mesh wire stuff on for the plants to grow on. But in general, the walls don't really need to be heavy if you plan it properly. So that most walls can suit vertical garden. This allows for land that isn't usually used, that can't be used to grow other crops, and people don't really want to live there, to be used for something that can be quite valuable, which reduces the amount of land we use. And then you can't really grow forests in a desert unless you try really hard. So this also allows us to utilize that land that won't usually be utilized. Yes?
About what is the optimal temperature to survive in deserts?
Optimal temperature, I don't know, I'd say it really depends on the species, but I think about 27 to 30 degrees will probably be the best for algae, because that's when their little body parts are really, they're really moving in that point. It's not too cold for them to slow down, it's not too hot for them to burn.
It looks very sad.
I have a question.
Just because the lid was on, couldn't read.
Yes.
Okay, so once you have the algae and everything and harvested, what is the process you do to take it from the algae to like a usable resource?
Like in the form of energy or fuel?
Yeah, or any.
Okay, well, the energy is with that compressor where they put it under big temperatures and big pressures, and then it basically turns it into oil. Like how in nature, the rocks and stuff have compressed over the dinosaurs, basically, which is also actually algae. Most of our oil comes from algae, and then it compresses it millions of years, and then that forms oil.
It was an amazing talk,
Thanks, sir.
and it's clearly you're passionate with it. I'm not a scientist or a biologist, so that part of interests me far less. What interests me is, how do we create the political will, or among humans, to embrace what clearly seems to be sensible scientific options?
Sure. There's a little movie put out about this I can't remember what it was called. I think Planet of the Humans, I think it was called, where they discussed why most sustainable energy isn't really that great. And it's basically a mask for governments to say, hey, we're doing this, but we're actually doing all the fossil fuel burning in the background. So it's similar to, it's like the way the fuel companies stop solar powered cars and stuff like that. Because if people really knew how bad it was, then they wouldn't really want to go to coal. A long time ago, not really long, like the 1900s, 1800s, 2000s, I don't know.
Hi, ma'am.
Yes, ma'am.
Sorry, is Little Pedro in your class?
Yes, he is.
Can I ask you to please send him down to reception with his bag?
He's coming, ma'am. Thank you.
Thank you.
In the 2000s, somewhere like that, 1930 or something, when fuel people were making the fuel and they wanted to see what the impact on the environment was, they employed scientists to do an environmental impact assessment. And they actually got very negative results, so they told them to be quiet. Yeah.
So it's lack of education.
Yes.
People don't know. There must be some form of economic payoff for us to continue the way that we are.
Oh, yeah. The fossil fuels are very easy to use.
Yeah. Last night, I didn't listen to the speech, but you might be aware of it. Boris Johnson, of all people, spoke to the UN last night. And it was all about conservation. And basically what he's saying is that we are behaving like reckless teenagers, and it's time that the world grew up. Because there are obviously, as you pointed out, energy crises and other things going on. But how do we then, and this is the other question, perhaps more relevant to the people in this room, how do we change our own mindset here at York in terms of the school? What can we do in the school? Should we not be doing some of these wall things in the school? And what would it take for that to happen?
Well, you could have like an environmental drive, but a lot of the time there's topics that are seen as more important, and a lot of them are like gender-based violence or racial inequality and stuff like that. So, and I don't think the environment is really on the minds of a lot of young people these days.
The funny thing is, if we all combine on a project that appears to be more neutral, like the environment, and people are working together, they are more likely to be tolerant, I hate that word, but more likely to embrace each other and the differences that people have. So it can be a vehicle for that kind of change as well.
Yes. It's a way to get people working together instead of, yeah. Well, it's actually a very good question. You will, when you burn it, you will produce carbon dioxide. But if you have a bunch of algae plants, factories and stuff, all of that carbon dioxide is being processed in there. So you're sucking that much out of the atmosphere and you're putting so much back in after you burn it. But there's still a constant amount that will be in those facilities, which will suck up a lot from the atmosphere. So it's also a way to reduce carbon dioxide.